Welcome to a new section of the course, Understanding Regression Analysis. In this section, we will introduce how to fit a linear model into data with the LM function. Next, for distribution in other than the normal Gaussian model, for example Poisson or binomial, we use the GLM function with an appropriate link function correspondent to the data distribution. Finally, we cover how to fit a generalized additive model into data using the GAM function. Now we move on to the first video of this section, that deals with fitting a linear regression model with LM. In this video, we will first perform fitting of a model using LM. We will also use the LSFit function to perform simple linear regression. Regression is a supervised learning method, which is employed to model and analyze the relationship between a dependent response variable and one or more independent predictor variables. One can use regression to build a prediction model, which can first be used to find the best fitted model with minimum squared errors of the fitted values. The fitted model can then be further applied to data for continuous value predictions. There are many types of regression. If there is only one predictor available, and the relationship between the response variable and the independent variable is linear, we can apply a linear model. However, if there was more than one predictor variable, a multiple linear regression method should be used. When the relationship is nonlinear, one can use a nonlinear model to model the relationship between the predictor and the response variables. Now let's look at regression from an amathematical point of view. The regression model has the response terms form, where response is the response vector, and terms is a series of terms that specifies a predictor. We can illustrate a simple regression model in the formula y equal to alpha plus beta x, where alpha is the intercept, while the slope beta describes the change in y when x changes. By using the least squares method, we can calculate beta as, where y bar indicates the mean value of y and x bar denotes the mean value of x. The simple model in regression is linear regression, which is best used when there is only one predictor variable and the relationship between the response variable and the independent variable is linear. In R, we can fit a linear model to data with the LM function. We need to prepare data with one predictor and one response variable, and with a linear relationship between two variables. So first, we need to install the car package. So the car package is installed here. We then load its library. So the library is loaded. From the package, you can load the quartet dataset. You can do that using data function. Then, you can use the str function to display the structure of the quartet dataset. You can see the output here. Next, we draw a scatter plot of the x and y variables with plot and append a fitted line through the LM and abline function. You can see the simple regression plot. The regression line illustrates the linear relationship of x and y1 variables. To view the fit model, execute the following lmfr command. You can see the output here. We can see that the coefficient of the fitted model shows that the intercept equals 3.0001 and coefficient equals 0.5001. As a result, we can use the intercept and coefficient to infer the response value. For example, we can infer the response value when x at 3 is equal to 4.5103. This is calculated as 3 multiplied by 0.5001 plus 3.0001. Besides the LM function, you can also use the LSFit function to perform a simple linear regression. So as you can see, we get the same output plot using LSFi. Awesome! In this video, we fitted a linear model using LM successfully.